On this 6.7 power stroke, P2598 means the PCM may be seeing a mismatch between where it wants the variable geometry turbocharger actuator to be and where the position feedback says it actually is. In plain terms, the VGT actuator may be stuck low or not tracking the command correctly. The truck may go into derate and may feel down on power. And after the repair, the warning message may stay on until the truck is driven long enough for the message to clear. Broadly, this can involve charge air leaks between the turbocharger and intake manifold, VGT actuator or position sensor circuits, a map sensor input, the turbocharger wastegate regulating valve solenoid, the actuator, or the PCM. Start with the basic system checks, follow a structured diagnostic approach, and use the P2598 path through the turbocharger actuator test. With the ignition on, check whether P2598 is present by itself or with other related turbocharger control, boost pressure, or command versus response codes. Don't read through a long code list here, just treat those as context. If this family of faults is present, continue into the actuator circuit checks. If there are symptoms but no codes, this same path can still be used. Also, if regeneration starts during diagnosis, let it finish before judging scan data, because the displayed values may be biased during regeneration. Next, verify the voltage feed at the turbocharger actuator connector. Turn the ignition off, disconnect the turbocharger actuator connector, then turn the ignition on. Measure between C1390 pin 4 as the positive lead and C1390 pin 3 as the negative lead. You're looking for 4.5 volts to 5.5 volts. If it's in that range, keep going to the open circuit checks. If it is not in that range, leave this path and diagnose the reference voltage or return side concern before continuing. Now, check the circuit continuity with the ignition off and the PCME connector disconnected. Measure resistance from C1390 pin 2 to C1232E pin 38, from C1390 pin 5 to C1232E pin 85, and from C1390 pin 1 to C1232E pin 106. Each of those circuits needs to be less than 5 ohms. If they pass, move on to short testing. If any circuit does not meet that limit, repair the open circuit, clear the PCM DTCs, and repeat the self-test. After continuity passes, check the same actuator side circuits for a short to ground at C1390 pin 2, C1390 pin 5, and C1390 pin 1. The decision point is greater than 10K ohms. If the readings are not greater than 10K ohms, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Then, check for a short to voltage with the ignition on at C1390 pin 2, C1390 pin 5, and C1390 pin 1. If any voltage is present, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, continue. For these short to ground and short to voltage checks, make sure the complete meter hookup is known before testing. The pin targets and decisions are clear, but do not guess at an unspecified lead placement. Next, check whether the actuator control circuits are shorted together. Measure resistance between C1390 pin 5 and C1390 pin 1. The reading needs to be greater than 10,000 ohms. If it is, continue to the actuator internal resistance check. If it is not greater than 10,000 ohms, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Now measure the turbocharger actuator internal resistance on the component side between C1390 pin 5 and C1390 pin 1. The full decision is whether the resistance is between 1 and 900 ohms for Transit Connect or between 1 and 1000 ohms for F650, F750, and F-Series Superduty. On this Superduty, use the 1 to 1000 ohms range. If the actuator is in range, continue to the intermittent harness check. If it is not in range, install a new turbocharger actuator. Carry out the VGT valve and MAF sensor reset and clear function with the scan tool. Clear the PCM DTCs. Reset emission monitors information in the PCM. And repeat the self-test. Reconnect the PCME connector and the turbocharger actuator connector. With the ignition on, monitor the PCM VGT POSV PID. While watching for voltage spikes, wiggle, shake, and bend small sections of the harness, working from the turbocharger actuator back toward the PCM. If you catch the concern, repair as necessary, clear the PCM DTCs, and repeat the self-test. If the harness check stays clean on this Super Duty, continue to the engine off actuator operation check. With the engine off and the ignition on, use the PCM controls to command VGT-DC command and monitor VGT pause V. Compare the position voltage to the actuator position table. At 0%, VGT pause V should be 1.1 volts to 1.3 volts. At 100%, VGT pause V should be 3.4 volts to 4.5 volts. If the voltage approximately matches the expected positions, continue to the actuator arm movement check. If it does not, carry out the VGT valve reset and clear function with the scan tool. Then move into the mechanical turbocharger VGT check. If the commanded position and feedback do not line up, turn the ignition off and disconnect the turbocharger actuator linkage. Check the turbocharger VGT for sticking or binding. Also inspect the compressor wheel and housing. Make sure the wheel spins freely, listen for noise while spinning, look for compressor wheel vane damage, and check for debris in the housing. If there is a VGT sticking, binding, wheel, housing damage, noise, or debris concern, install a new turbocharger, carry out the VGT valve and MAF sensor reset and clear function with the scan tool. Clear continuous DTCs, reset emission monitors information in the PCM, clear PCM DTCs, and repeat the self-test. If the turbocharger checks good, install a new turbocharger actuator and perform the same reset, clear, monitor reset, and self-test routine. Keep verification separate from the circuit testing. With the ignition on, command the VGT-DC command PID-I duty cycle to 0% and record the turbocharger actuator arm position. Then, command it to 100% and record the position again. If the arm changes position when commanded, the system is operating correctly at this time, and you can go back to symptom diagnosis if the complaint is still present. If the arm does not change position, install a new turbocharger actuator, carry out the VGT valve and MAF sensor reset and clear function with the scan tool, clear continuous DTCs, reset emission monitors information in the PCM, and repeat the self-test. There is also a connector operation check after the main actuator movement check, but the entry point into that check is not clear. If you land there in your diagnostic flow, pause, recheck the earlier path, and avoid guessing. The check itself is straightforward. Inspect for pushed-out pins and corrosion. Connect the turbocharger actuator connector. Make sure it seats correctly. Then run the PCM self-test and see whether the concern is still present. If the concern is still present, install a new turbocharger actuator. Carry out the VGT valve and MAF sensor reset and clear function with the scan tool. Clear continuous DTCs, reset emission monitors information in the PCM, and repeat the self-test. If the concern is gone, the system is operating correctly at this time, and the issue may have been caused by a loose or corroded connector. The clean way through P2598 is to prove the actuator feed, prove the circuits are not open or shorted, verify actuator resistance, catch any intermittent harness movement, then compare commanded VGT position to feedback and actual arm movement before condemning the turbocharger or actuator. For more diagnostic training, visit stepdiagnostics.com.